Let's try to understand, recap how we have stored the data into the cluster and using Hadoop, and how the data has been broken and how the data has been chunked into pieces and how it has been stored into the HDFS. Just a few minutes of recap, then we'll move to MapReduce. Okay, then what is a MapReduce? We are going to see what is a MapReduce and what are the different phases of MapReduce, and we'll be first we'll be trying to understand the MapReduce framework. Then we'll get into the program. We'll take one scenario and we'll try to understand that. Then we'll move to a programming part. Okay. Do you guys anyone can explain me how the data will get stored into HDFS? Anyone can explain me how the data will get stored into HDFS? Okay, fine. Let me take. I'll explain that. Let's assume that I have a file. Which let's assume that let's take an example of AMP file, and I have a client. So it is a size of 1 GB size, and I have a block size is 64 MB, and replication factor is 3. And I'll ask my client to I want to store this file into HDFS. The client will go and interact with your name node. Your, your client will talk to the name node saying that before interacting to the name node, what your client will do, it will break the your file into chunks, smaller chunks, okay, into blocks. It will get divided 16 blocks. It will get divided into 16 blocks, and it will take first block and it will go and talk to the name node saying that I would like to store this block into the cluster. Then your name node will refer its meta save or metadata, and it will see which other data nodes are free. Depends on the block replacement policy, it will give the data nodes to the client. Let's assume that it has given some data nodes. It has given some data nodes to client. Then your client will start storing the block into your client will directly talk to the name node, data nodes, and it will start pushing the data into the cluster. Your client will store the data into the cluster, right? And failure scenarios and all will take it later. Let's assume that it is successful storing and the data has been stored successfully. And as soon as the data has been stored successfully, I mean, when the block is stored successfully, your data nodes will keep posting to a name node saying that this is the block I have stored. Let's assume that here the block 1 is stored in this machine, block 2 here, block 3 here, right? This is the way the data will get stored in HDFS. Is this clear, guys? Do you guys have any doubt here? Okay, now the data has been stored successfully. Then now how to process the data. As we know that how to come up with the two components. One is the HDFS to store the data. Another one is MapReduce to process the data. Another one is MapReduce to process the data. Let's try to understand what is a MapReduce conceptually. Then we'll get into the program. Okay. Now, whatever the data I have stored in the cluster, I have to pick and I have to process it, right? The processing framework is called a MapReduce framework. We will see in detail what is the MapReduce framework. Let me share a PPT. We are going to see what is MapReduce, how it will process the large amount of the data in the cluster, and what are the different phases. And we'll see an example. We'll see the architecture, flows, and we'll see different kind of concepts in this. Okay. What is a MapReduce? MapReduce is a programming model or program or a programming framework which will process a large amount of the data or large amount of data sets in a cluster in the parallel fashion. Your MapReduce programs are designed to process large volume of data in the parallel fashion. Where it will process? It will process in the cluster. How it will process parallelly, we'll go ahead and see. If we take, in our case, what we are using for the storage, we are using HDFS for the storage, which is we are using commodity hardware, right? So in this commodity hardware, we are launching a job or we are launching a action which will process the data in a parallel fashion, the whole cluster. How it will process? Let's go ahead and see in. Let's see how it is processing. Now the data has been stored into the whole cluster. Now the data has to process, right? What we will do, we will write our MapReduce logic. We will write our MapReduce logic. Let's assume that I have written my MapReduce logic. Then we'll tell to the client saying that launch this job in the cluster to process the data. Launch this process. This is a logic, MapReduce logic. We'll tell to client launch this apply this logic or apply this computation on the data which is stored on the cluster. Then what will happen? This logic will go to the name node. We'll see the complete flow. I'm just giving an introduction. This client will talk to the name node saying that I want to apply this logic on the data which are stored in the cluster. Your name node knows that where and all the data is stored, and will give the for this logic will give the input path. Input path contains which data you want to process, and output path. The output path is after processing where you want to store the data. We'll give these two parameters to your logic. Where the data is there, I mean what is the data, location of the data, input data, and we'll give once the process the data where it has to store. That information will give along with the logic. Then your client will take input and will says that, well, this is the data I want to process. Please tell me where and all the data is there. Then your name node knows where and all the data has been stored, and your MapReduce logic will go and apply those places where and all the data is available. Let's assume that here I have one block, here I have one block, here I have one block. Your MapReduce logic will go and execute here, here, here. Your data will get processed. Your map logic, what are the logic you have written, the logic will apply here. Your logic will apply here, and your logic will apply here as well, and your logic also will apply here as well. Even though this is a chunks of the data, even though those are not complete data, complete employee data, even though these are small blocks of data, your data will get, the small chunk of the data will get processed using the MapReduce. The MapReduce framework has internally has a different phases. We'll see that. Now we are looking at the high level and how the whole logic will apply. And your MapReduce logic will apply those small chunks, and it will start processing them. Will process those small chunks, and after processing the small chunks, it will combine the results. It will aggregate the results. It will sum the results, and it will emit the output. Clear how your MapReduce is processing parallelly? Because where and all the data has been stored in that data, in that specific data, your MapReduce logic is going and processing in that blocks. These are not threads, these are processes. Whenever you submit the logic, your name node actually is a job tracker. We'll see in detail. Let's, for timing, just assume that name node only, or else you can treat it as job tracker. The job tracker is called JT. Job tracker will launch the child JVM. It is a JVM, complete processes. It's not a thread. Thread is completely different, and complete JVM is different. Complete process. The process may contain small threads, multiple threads, right? So it will launch your job tracker, who is taking the control. Your job tracker will launch the jobs to process on the name nodes, or sorry, data nodes. It launch the, your job tracker knows where, and your job tracker will talk to the name node saying that where and all the data is there. Take the data, tell me, and your task trackers. Actually, the task is processed by task trackers. Actually, the data has been processed by task trackers, and your job tracker will tell to the task tracker saying that this is the location of data is available. This is the resource of that. This is the logic. You go ahead and apply your logic on the blocks where and all the data is there. Then your job tracker will start executing that program, your MapReduce program. Your job tracker will start executing the MapReduce logic on that specific data. It's not only one machine. It depends on the cluster size. It depends on the mapper slots available. Here we need to understand slots, map slots and reduce slots. We'll talk about more about the slots tomorrow class. But time being, just understand your job tracker will launch the jobs on data nodes using task tracker daemon. Task tracker daemon.
Vera, sorry to interrupt you.
Yeah, go ahead.
Please, could you repeat from job tracker onwards?
Okay. Yep. Once the job has been submitted, your job tracker will come into picture. Your job tracker will talk to the name node. It will take where and all the data has been stored. The locations of the data has been stored, it will take, and it will inform to the task tracker, this is the place the data blocks are there. You go ahead and launch this job. You go ahead and process that data. It will take the business logic, and it will apply the business logic and all where and all that the data has been stored. In our case, block 1, block 2, block 3. Clear, Chandu? Anyway, we'll see
Yeah,
complete
the
flow.
client.
Go ahead.
Okay. The client will approach job tracker or directly later no?
See, the client will talk whenever you submit the Hadoop job. Your
Okay.
client will approach the job tracker. Ideally,
Yeah.
normal cases, the job tracker will be running on the name node. Okay,
Yeah.
and your job track will talk to the name node to get the locations, and your name node will schedule the jobs. Ideally, it's a job tracker only. We'll see that in detail. Job tracker is
Okay.
nothing but a
Clear. Clear.
daemon. Job tracker is nothing but
Yeah.
a
Yeah.
daemon.
Okay.
Okay, one service, daemon service. and it will process the, and it will apply the business logic, which is a map reduce, and the specific blocks your map reduce logic will apply it, and it will, let's assume that my map logic is applied on this block. It will give some data. Let's assume that it will give some of the output. It will give some output, and it will also give some output. Like that, each map will emit the some output. The emitted output will be there for in their local file system only, in the data nodes. In the data nodes, we'll see in detail about that. And let's assume that this data node is emitted some data as output, and this is emitted some output as intermediate data, and all your outputs will get collected, and it will be combined. It will give us a single output to end user. Clear, guys, how it is parallelly processing the data? Is this clear, guys?
Sorry for disturbing.
Go ahead,
Can
Jay.
you just no no? Can you briefly explain like actually 1 minute actually? It's not briefly. I actually I missed actually.
Okay, 1 second, guys. Okay. See, we have a basic how we know we have a knowledge of how the data has been stored in the cluster, right? When you have one file, which is the employee file, which is a 1 GB of file, that file has been stored in the cluster in the form of blocks. Those are like B1, B2, B3, and so on, B16. Let's assume that the data has been stored in the cluster. Now I want to process the data. I have written my business logic using MapReduce.
Okay.
This MapReduce logic, I'll submit the job to the cluster through client.
Correct.
I have a command called Hadoop jar and jar file. We'll see that how to apply.
Okay.
So I
Okay.
have applied this job into the cluster. Then when I apply the job, your client will talk to the name node. Ideally, it is a job tracker, which is a daemon. Your job tracker will create a job ID, and this is a source file, right? Like this is the resource. Your logic is a resource, and your logic has which is the input and which is the output folder. And this input folder is contains the location of the data. I mean, actually, it's not contain the location of the data. This data I want to process. In our case, employee data. And your job tracker will says that will talk to the name node saying that get me the locations of the employee data. It will take the locations of the employee data. Then your job tracker will launch the jobs which are called task trackers. Your job tracker will launch the tasks
Okay.
because your job tracker knows that where and all the data is there. And the task trackers are the small sub daemons. I can say task trackers are the daemon which are running on the data nodes. Job tracker is the daemon which is running on the name node, and task tracker is the daemons which are running on the data nodes. And each data node, the task tracker will be there. Now, where and all the data is there, the job tracker will ask those task tracker to process the data. Apply this business logic. Take this business logic, apply the business logic on your blocks.
Okay.
Then, when I am process this business logic in this small block, it will emit some data as output, and this small block also will give us output, and this small block also will get processed and give the output. All the output will get combined or aggregated, and it will give the final output. This is how the
So you
data.
mean to say
Go ahead, Jay.
you mean is the final output will come through like output through MapReduce or like it become output for like it will display or like how it will store.
No,
Is it
you have given output path here,
what
right?
format of data will get like if they get some process we are getting so
Yeah. See, the output you have given output path here. where whatever the output, final output comes, where you want to store that output path, you have given output path here, along with your logic, along with your job, I can say. Okay. In that path, in a HDFS, in that path, it will store the output. Let's assume that you have given sample, processed, OP, output. So in this output, the data will go, output data will go here.
So basically, like your output will be, it will store somewhere, or it will only display or something.
No, it will store in some place in the HDFS. You'll give the output path, right? You have given output path
Okay.
here.
Okay. Okay. Got it. Okay.
Okay. And also the format of your question, other question was what is the format of the data? Output format. The output format we have to specify. By default, it is a text, and we can specify that as well. And the input format, output format, we have to specify. Those things we'll see in the coming classes. Is this clear, guys? Jay, is it clear? Bharat, Jay, Mani. This is the high
Yeah,
level.
yeah.
This is the high level how the MapReduce job will work. Now we'll go and see the detail how your MapReduce job will apply on the blocks. We'll see that. This is a high level. Once the data has been distributed in the HDFS, on top of the whatever the data is available on the cluster, on top of that we are applying our business logic. How it is processing we have seen, and how it is actually processing we'll go ahead and see. We have seen how it has been parallelly processing the data, and this framework also contains some internals, some different kind of phases to process the data. Those phases we'll see now. Clear, guys? Okay. Next move. uh, Let me queue. This is our cluster, how the data will be stored. In our cluster we have a data node and task trackers, data node, task trackers. These are different racks, and this is how our cluster will looks in real time. And these are the data nodes, right? In these data nodes the data will be stored. Let's go and see. These are the data nodes. Let's assume that these are the blocks the data has been stored. Different machines, the data has stored in different machines. When I launch the MapReduce job, it will go ahead and execute on this place, and it will go ahead and execute here, where and all my data is available. The input data, along with my business logic, I'll be giving input path, saying that this is my data. I want to process that data. In our case, we have taken employee as an example. That employee data has to be processed, and after processing where it has to store, we have given that path as well. The employee data, it is already there in the cluster. The employee data is already there in the cluster, and your name node knows where and all the data has been stored, and which are the data nodes the data block has. And when you launch the job, where and all the blocks are get stored in those machines, your MapReduce logic is go and execute parallelly. Okay. Yeah, let's assume that these are the data blocks, and your MapReduce job will come and process in these blocks here, 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 and here. Okay. Now try to understand there are different phases of MapReduce. Let me explain you. Let me go with a diagram. I'll take a diagram and explain you. So we have seen why it has been named as a map and reduce. We'll all see now. We know that the data blocks are, let's assume that these are the data blocks. This is block 1, block 2, block 3, and block 4. Let's assume that these are the different blocks which are stored in the different machines. When I apply my MapReduce job, my MapReduce job has internally different phases. What are those different phases? One is the map phase. What the map phase will do? If you take a scenario, what is the MapReduce will do? Divide the, while storing the data itself, we are dividing into the blocks. And now we are processing the data in a parallel fashion. Whatever the data has been processed, stored. It is like a divide and conquer. You have a huge amount of the data you stored in the cluster, and you have split your process data into pieces and process it separately. The same way here, the whole data which is we are stored, divided and stored in the cluster. Now we are going to process that small pieces. We have divided the work, and that work which is divided, and we are processing that work. Let's see what are the blocks are there. My MapReduce framework has different phases. As I said, map phase. After map phase, there is one more phase called reduce phase. In between, there are a couple of processes. We'll see them. The first phase of MapReduce is mapping. First phase of MapReduce is mapping. What is mapping? To whom it is get mapped? What is mapping phase? What is the mapping phase? This map phase, what it will do, whatever the input you have given as part of your input job, your MapReduce job. Let's assume that. Hello. Along with your job here, let's assume that it's a more job. Along with your job, you have given input and you are going to give output path. Input path and output path. This input path will represent the file name or location of the file. And the data is stored in cluster. The data is stored in the form of the blocks. Now, my map phase, what it will do, each block, each block will map with my map function. In my MapReduce, I have a different functions. Map function, reduce function. Before that, there is one more function. We'll go ahead and see them later point of time. My framework is a map and reduce framework. First, what it will do, whatever the input we have stored in the cluster in the form of chunks, form of the blocks, each block will map with my map logic, mapped with my map function. It will get mapped with the map function, and this also will get mapped with the map function. This map phase, each block is mapped with our map function in the MapReduce framework. We'll see what is a map function in the MapReduce, what is a reduce function, what are the input those will take. We'll see in detail. Now we're just getting into the MapReduce. We're just trying to, it is an introduction. We're trying to familiar with the MapReduce framework. Then we'll see the detail. In our MapReduce framework, we have a map function and reduce function. Ideally, the framework, the name itself is saying that map function and reduce function. What this map function will do, it will start get mapped with each block. It means that your map function will work on each block, and whatever the logic you write in your map function, the logic will get executed. And your map function, your mapper will emit some output. Your mapper function will emit some output. That's called intermediate data. That's called map output or intermediate data from the mapper. That's called intermediate data from the your mapper. Why it has to map? Because each block has to be processed independently. That map function, what are the logic you have written, whether it is a it's kind of count or it's kind of process, it's kind of select, whatever the logic we have written, that map logic will process that data and it will give an output. Let's assume that this is output 1, output 2, output 3, output 4. Let me take it. Now my data has been mapped with each map. The mapping phase is done and it has executed my mapping logic. I mean my mapper logic. Whatever the map logic I have written, it is executed that mapper logic and it has given some outputs. That's called mapper output or intermediate data. This data will start copy, or this data has to be aggregated properly. Right? Let's assume that I have taken a scenario. I want to find, let's take a scenario. I have a e-commerce application, e-commerce application, which is amazon.in or amazon.com. Let's assume that. And I want to know from last 1 month or last 1 year, which of the product has been sold more. Customers are, which are the products that they are buying more from the amazon.com. So they have given data. This has a category of, it has a category of mobiles. It has a category of mobiles, books. It has a category of households, home appliance, home appliance. It has category of speakers. Um, let's take something else. Okay, different categories are there. I want to identify last year how many mobiles has been sold, how many households has been sold, and how many books has been sold. I want to know the statistics of each category last year. The whole data will be 1 GB or 10 GB. Let's assume that it is 1 GB because we are taking 1 GB frequently because it's a small data. We can easily understand. That data will broken into pieces and stored in the cluster. So those are different blocks, right? And let's assume that this block will contain mobile. This block will contain mobile or households or books also it may contain. Your block also may contain books, households, and some of the speakers are some XYZ. This also may contain XYZ. This also may contain XYZ. Right? When I apply my business logic on this block, I will get only result of this. I'll get only result of this. I'll get only result of this output as an output. But it has to be combined, right? These are the pieces of data. These are the small piece of the data. If I do a logic on whole data, then I'll get the accurate results. But if I do my logic on small data, I'll not get, because my data has been splitted, my data has been broken into small pieces. This piece may have mobile, household and books, other piece may have books, household again, right? When I implement how many mobiles has been sold, it will give only this block. But what I'm looking for whole data, I'm looking for whole data. Guys, if you are able to understand this point is very much important. I have a 1 year data. I want to know which category has been which category has get sold more in the last 1 year. Now what we will do, the whole, if it is a whole data, then let's take its process, it will give only one output. But here the data has been broken into pieces. In each piece the same logic is applying. In each piece we are applying the same logic. Then what it will do, it will give output of what are the data is there here. It is the output of what are the data is here. with whatever the data it is get. So, but I need a final output, right? Again, I need to club myself. I don't want to do. So for that, we have a phase called reduce phase. What this reduce phase will do, it will start collecting these outputs. It will start collect the outputs. In between, we'll be having sort and shuffle. We'll talk more about that in coming slides. In the reduce phase, we will combine. We'll combine these outputs. Output 1, output 2, output 3, output 4. All these outputs will be combining. Will be combining. Then only I'll get the proper output, right? Because I have a two mobile has been sold to here 3, here 4, here 1. So now when I combine this, then only I can say mobiles has been sold this many. 2, 3, 5, 9, 10. So 10 mobiles has been sold. Then only I can say last 10 years, last 1 year, I have sold 10 mobiles. I can say that, right? So to do that, what I have to do? I have to do a summation. I have to do aggregation. Where we will do aggregation? The aggregation will do in the reduce phase. In the reduce phase, we have done the aggregation. That output will be stored again in your output path. Wherever the output path you have given, it will get stored in output path. Are you guys clear about the map phase and reduce phase? This is much important. We need to understand this. Then when you go for the programming, it will be very easy to correlate. Are you guys? Is it clear, guys? Bharat, you want to talk something? Okay. Okay. Now the map phase and reduce phase we understood. In between, there is a phase called sort and shuffle. What this sort and shuffle will do, we'll see later. Because you may get confused if I explain this.
Right. Only like reduce means is it aggregator sort of thing? Only filter and aggregator. Am I
It's
correct?
it's kind of filter and aggregate. This kind of filter, summation, or you can apply any of your logic, whatever the logic you want to apply. Red is also another kind of function. Actually, this is also one kind of function. Here also you'll write your own logic, what you want to do. After getting the sum or after getting the results, what you want to do here. That's also some logic you have to write. Here also you have to write your own logic. And this phase, what are the logic you'll write, that output will be given to you as part of the part files. It's called the part files. Output part R hyphen R means it will give like this. Okay, part hyphen R001 or something. And when it comes to the map output come as a part. It's a part only, right? It's not full data. That is the reason to give as a part. M means mapper output. When you see R is a reducer output. The mapper output temporarily will store in the local memory of data node. Please try to remember this. This is very much important, guys. It will not store in the HDFS. It will store in the data node's local memory. The mapper output will store in the local memory of the data nodes. This is one of the interview question. Where the mapper output will store? It will store in the data nodes only. Okay. We will see detailedly. There are not only sort and shuffle, not only these three phases. We have another two more phases will come into picture here. We'll see them one by one. Are you guys clear about up to here? How the
Yeah,
map will
sorry to
describe?
interrupt you. Yeah,
Yeah, go ahead, Chindu.
yeah. You said that the mapper output will store in the data node.
Mm-hmm.
Yeah, the output of mapper was taken by the reducer at the time the output of mapper is available in data node.
Yes, that will be available in the data node. It has to be available in the data node. Your reducer,
Okay,
what will do before the reducer phase, before the sort and shuffle phase,
okay,
you have one more phase called copy phase. Okay, what it will do, whichever the mappers are completing their jobs, it start copy the data. It will copy the data, and again this reduce also has to this reduce job also has to launch on the data nodes only. The reducer job has to launch in the data nodes only. It can be this data node, it can be any of the data node. These are some simple tasks, these are simple business logics. They have to execute in any one of the data node. Your map logic is executed on these data nodes. Let's assume that this is the data node 1, where where your block 1 is there, and let's assume this is data node 2. Let's assume that this is data node 3, and let's assume that this is data node 4. And your reducer logic also has to launch any one of the data node from these data nodes, or it can choose from the different data node as well. It can be different data node as well, and it'll start. Let's assume that my reducer logic is implemented in here data node 4. Let's assume that here it has been launched, but it has to copy the data from here, from this data node, from here, from here it has to copy the data node to this, wherever the your reducer is executing. And here we are losing data locality. If you remember, I thought you guys will ask here. Fine, it's okay. So here we are losing data locality because my mapper logic is executed wherever the data is there. Fine, I'm data locality, now I achieved the data locality. But the reducer is not launching on the same data nodes. The reducer can be launched anywhere. The reducer tasks will be lesser than your mapper logics. Before, mapper logic will launch how many blocks are there, those many map tasks will launch. But reducer task will launch less or more. It will be one or more. It depends on the data and depends on the configuration. We'll see them. Your reducer task will be launched any of the data node. It's no need to be no need to be the same data node. So when it launched on one data node, it has to copy the output of other data nodes to that data node. So we are losing a data locality here. But even it's a fine because the emitted output can be very small. It can be 64 MB or 100 MB, right? It's a less amount of the data. Fine. It is not like a 10 GB I'm copying, or it's not like 1 TB I'm copying. It is just one block. Small amount of the data only I'm copying. It is okay with our cluster. That it's I can say it is okay with the reducer phase. Clear, Chindu, your doubts?
Yeah, clear.
Yeah. When we take an example, right, when we'll take one real time example, that time it will be very easy to understand. We will take one word count example, which is a hello world for Hadoop. We will take a word count example. I'll explain you detailedly, then how it is broken, how it is storing the data. Then we will see hands on. Is this clear, guys? And in between copy phase, I said, as a copy phase is there, and before that there are some more phases we will see in detail in a later point of time. If you guys have any doubts, go ahead and ask me. I'll This is a process, we'll see them in detail. What is a map task, what is a reduced task, in detail we'll see them. And before getting into them, I want you to ask, if I want you to make sure that you have understood the process. There is a sort and shuffle phase, in between there is a merge, and there is in between a copy phase. We will see them detailedly when I take the example. Is this clear, guys? Okay, we will see. I have doubt in how to go ahead, Chandu.
Are you trying to tell anything?
No, no. We go ahead. Ask me the doubt.
Yeah, one thing, in interviews, I had seen this question, like why is Hadoop using its own framework?
Why Hadoop is using?
Own framework.
Why Hadoop is using own framework? Hadoop itself is a framework. If you want to
Okay,
process a large amount of data in the parallel fashion, we have two components. One
okay,
is a MapReduce and one is a HDFS, another one is a MapReduce. And
okay,
the Hadoop framework has been designed using these two frameworks. I mean, these two HDFS and these two components, HDFS and MapReduce. And
okay,
the HDFS will tell you to the how to store the data into the cluster, like break the data into pieces and store in the cluster. First of all, why Hadoop came into picture? We have seen in the early day, very first classes, due to the data
yeah,
local, we are losing. It's taking time consuming. It is to process the huge amount of data. We are not able to process the huge amount of data using traditional approach. That is one problem. Another problem is the cost. So when the data is growing, we have to replace the whole existing system. The other problem is even though we have replaced the whole huge amount of this huge system with the bigger systems, the time consuming because we are missing the data locality and there is no parallelism, there is no distribution, there is no fault tolerant. These are the issues with the existing traditional approach. To overcome
okay,
those issues, we come up with a framework called Hadoop. And Hadoop internally uses HDFS for the storage and MapReduce for the process.
okay,
So why it is using its own framework? I didn't clear about the question, but let me try to understand this way. So when you store the data into the multiple machines in a distributed manner, if you want to process that data in the same distributed manner, you have to go with the MapReduce only. Like it can be a MapReduce, it can be a Java, it can be the MapReduce program which is designed in Java. It can be that. It can be Python script. Even Python or through Python also you can write your MapReduce jobs. Or Scala, there is a new technology. Scala Spark is coming to, into picture for the same purpose. Even the Scala or your Spark is using MapReduce API only. Even it is using MapReduce. Even if you take a Hive, internally using MapReduce only. Even if you take Pig, internally it uses the MapReduce only. The blocks has to be mapped and it has to be processed and output has to be reduced. That is the reason it is using its own framework. It's not like its own. It's coming from the different vendors. The Hive came from the Facebook. Pig came from the Yahoo. The whole framework of MapReduce came from Yahoo only. Your HDFS and MapReduce came from Yahoo. Clear, Chandu?
yeah, okay,
These are the compatible with our existing system. That's called ecosystem, right? These are the compatible with our storage and process components. Your Hive, your Pig, your HBase, your Spark, Mohot, whatever comes with. Those are familiar. These are compatible with this. So we can go ahead and we're using them. It doesn't mean that I cannot go ahead and use Spring. I can go ahead and use Spring also in the by Hadoop. Clear, Chandu? So we will see the other phases tomorrow. And I'm stopping my session. I mean, I'm ending the session now. So if you guys have any doubts, please stay back. Others can leave for the day.